Welcome to the class. Today's topic is evidence for quantized electronic energy levels. Evidence for quantized electronic energy levels. Okay, evidence for the quantized electronic energy levels. Atomic spectra. What is the meaning of it? The energy levels are quantized in an atom is given by the atomic spectra. Atomic spectra says the energy levels in a particular atom is quantized, which is indicated by the atomic spectra. Okay, how do we study the atomic spectra? Now let us focus when white light is fall on a prism. White light fall on a prism. White light can split into 7 colors: V, I, B, G, Y, O, R. Okay, these 7 colors are known as spectrum. Spectrum means these 7 colors are known as spectrum. Okay, whenever white light fall on a prism, it can split into 7 colors. These 7 colors are known as spectrum. Okay, next point. These 7 colors has energy ranges. These frequency ranges of these 7 colors is red color 7.5 to 10 to the power of 14 to violet color this one. This end and this end energies are indicated here. Okay, next one. We know atoms or molecule can give the spectra. Atoms and molecule can give the spectra. Molecules can give the spectra is known as molecular spectra. Atoms can give the spectra is known as atomic spectra. Okay, atoms gives atomic spectra. Atomic spectra. Molecules can give molecular spectra. Molecular spectra. Okay, atoms can give atomic spectra. Molecules can give molecular spectra. Okay, how the spectra is arrived? How the atomic spectra is arrived? How molecular spectra is arrived? Okay, let us look into this one. First of all, focus. We are in atomic structure, so atoms can give the atomic spectra. We will focus the atomic spectra. Okay, we will focus the atomic spectra. Okay, next. Atoms can give the atomic spectra. That atomic spectra is known as line spectra. This is known as line spectra. Atoms can give the atomic spectra. Atoms can give the atomic spectra. This is also known as line spectra. Okay, this is also known as line spectra. Okay, line spectra. Okay, line spectra are 2 types. Line spectra is 2 types. One is absorption spectra. Second one is emission spectra. First point is absorption spectra. Okay. Second one is emission spectra. Absorption spectra and emission spectra. In absorption spectra, dark lines appears. In photographic plate, dark lines are observed in absorption spectra, whereas bright lines are observed in emission spectra. Okay, let us focus how dark lines are arrived in absorption spectra, how bright lines are appear in emission spectra. Okay, let us focus absorption spectra and emission spectra. Okay, let us focus the concept absorption spectra, which is absorption sample. This is absorption spectra, and this is belongs to emission spectra. Okay, emission spectra for the atom, for the atoms. Okay, whenever we focus this sample to the electromagnetic radiation, whenever we focus this sample for the electromagnetic radiation, okay, let us say electromagnetic radiation is come like this, and the sample, whatever the sample, some atoms are taken here, the sample contains atoms. Okay, sample contains atoms. Sample contains atoms. Okay, this is known as sample. Okay, sample contains atoms. Whenever the electromagnetic radiation fall on a sample in this sample, atoms in gaseous state, atoms are in gaseous state. These atoms absorbs the sum of the electromagnetic radiation. Atoms can absorb the sum of the some quantity of electromagnetic radiation of these gaseous atoms. Okay, then these in this whenever atom absorbs the radiation, here atom contains electrons in different energy levels. Whenever atom absorbs the some radiation, in this electron goes from the lower energy state to higher energy state. For example, it is 1s state, it can goes to Ts1. Like this, electron goes to lower energy or ground state to excited state. Excited ground state to excited state. Atom can go from lower energy state to higher energy state. So some energy is missing from whenever electromagnetic radiation is fall on a sample, the outcome of the radiation has lesser energy than compared to this one. Okay, because some of atoms in gaseous state are absorbed some of the energies of electromagnetic radiation, which is utilized for the jump into the lower energy state to the higher energy state. Okay, that is the reason why some of the energy is missing whenever light comes out of the sample. When light comes out of the sample, some energy is missing. Okay, because of this electromagnetic radiation, we get the spectra. We get this spectra for this one, for this emitted radiation. For this emitted radiation, you can get the for this emitted radiation. Okay, here the projection is white light is fall on a sample, then some energy is missing like this, then after energy absorbed by the atoms, the remaining energy comes out like this, which is detected, and what is the energy of the electromagnetic radiation. Okay, from this electromagnetic radiation we get this spectra which contains dark lines, okay, dark lines. Okay, previously we saw dark lines are appear in absorption spectra. Why dark lines are present in absorption spectra? Because whenever white light fall on a sample, sample contains atoms in gaseous phase. These atoms can absorb the sum of the energies, certain energies, and the atoms utilize that energy to go to electron in lower energy state to higher energy state, Okay, That is the reason why they utilize that energy. So after coming out of this sample, the electromagnetic radiation, some of the energies are missing, because atoms are utilized that energy for the electron goes to lower energy state to higher energy state. So remaining electromagnetic energy comes out of the sample, and which is projected on the prism and then split up into 7 colors. Okay, which contains these colors contains lesser energy. Corresponding this spectrum, we can get the spectra, absorption spectra contains dark lines, because some energy is missing, because atoms can absorb some energy. So that is the reason why some energy is missing. So the missing energy will be indicated as dark lines. So dark lines indicates some energy is missing. Whenever white light fall into the sample, okay, all the energy is not comes out of the sample. Some amount of energy is absorbed by the atoms. It is utilized for the atoms to goes to lower energy state to the higher energy state. Okay, that is the reason why you can get the dark lines in atomic spectra. Okay, what about emission spectra? What is the meaning of emission spectra? How it is arrived? Let us focus emission spectra. Okay, in emission spectra is also having same story. The story is whenever light fall on a sample, electromagnetic radiation, light or electromagnetic radiation can fall on a sample. Ground state electron in a particular atom, ground state electron goes to higher energy state. Okay, we know that excited sample, that electron after some time comes back, returns to the ground state. Okay, that electron, whenever electron absorbs the radiation, whenever light fall on a sample, okay, the sample contains atoms. In atoms, electron goes to lower energy state to higher energy state. That higher energy state is not stable. Okay, that electron comes to ground level. Whenever electron comes from higher energy state to lower energy state, it can emit the radiation. That is the reason why they have taken excited sample. This sample is already absorbs the radiation. Then what it do? It emits the radiation. Next process is it should emit the radiation. Any electron, whenever electron goes to higher energy state, it cannot stable. It cannot live there. Okay, it comes down. Okay, that is the reason why excited sample contains the atoms. Atoms contain the electron in excited state. So these atoms goes to lower energy state. It should emit the radiation. That emitted radiation is captured here. This is fall on a same prism and then gives the spectrum. This spectrum contains bright lines. Okay, this spectrum contains bright lines. This is known as emission spectra, because the spectrum is arrived because emitting of the energy. Okay, atoms can emit the radiation. Okay, then only you can get the this type of spectrum. This is known as emission spectrum. Emission spectrum contains bright lines. Emission spectrum gives the bright lines. Okay, absorption spectrum gives the dark lines. We know why we can get the bright lines here. Why we can get the dark lines here? These lines, absorption spectra and emission spectrum lines are specific. For particular atom contains specific lines. Okay, sodium can give the emission spectra. For example, emission spectra, it has some certain of lines. Okay, sodium can give the emission spectra certain lines. Okay, 3 lines are nearer, and for example, I am saying for example, the lines for sodium atom is like this. For a potassium atom, okay, they can give, okay, these lines and these lines are not same. Both can give emission spectra. The spectral lines are different. So that is the reason why you can distinguish. This is the emission spectra of the sodium. This is the emission spectra of potassium, or something else. Okay, like our printing fingerprints, atoms can also give the atoms has emission spectra. Okay, which is specific. For a particular atom can give, always gives the particular lines. Okay, 3 lines near and 2 lines are farther. This is an example, not similar. This is the example what I am explaining. Here, in case of potassium, 2 lines are nearer and 1 line is center and 3 lines are far away. So this is the way, this is the example I have given. This is the rough analysis. Okay, from this we can understand that sodium has specular lines, potassium has specular lines. Okay, atoms, different atoms can give different lines. Okay, not all atoms can give all similar lines. So the lines are line spectrums. The line spectra of each atom is different. Okay, sodium gives one particular lines, potassium gives another particular lines, rubidium can give another particular lines. This is the reason why till now, even today, emission spectra is utilized in various laboratories in India. You can find out how it is sodium or potassium is available in earth crust, or it is radium, or whatever it may be. It is analyzed by taking this type of emission spectra. This type of emission spectra can help to the scientist to you can find out our earth contains such type of metal is correct or not. You can decide it taking the sample, and you can do this type of experiment, and you can get the spectra, emission spectra. Then compare it to the previous history. Okay, sodium has certain lines. Here the sample contains same lines. Then it is a sodium. Then it is a, if potassium contains the set of lines, we have previous data. Next our sample contains same lines. Then it is a potassium. So in this way, utilize the atomic spectra to analyze the sample, which element it is. Okay, our earth crust contains different elements. Okay, it is a titanium or mercury or whatever it may be the elements. You can find out which element it is. How we can find out the elements? By taking this emission spectra or absorption spectra, you can compare the previous history, which particular element has particular spectrum. So let us compare this one. The present sample can give the certain spectra. So let us compare the previous history of the atomic spectra and then compare these two, and you can get the results. So that is the reason why line spectra or atomic spectra is used in nowadays also. Okay, that is the class. Thank you.